Katka, and this is activity recognition using motion history images, final project for CS6476. Motion history images are static representations of temporal activities. To generate an MHI, you take an input video and you subtract consecutive frames. To isolate your subject's motion, you go ahead and threshold that image and add it to a list. When you iterate through that list, you degrade the pixel values in an image based on how recent it is. What you're left with are these motion trail images where brighter pixels represent more recent activity. We can then pass those MHI, those static images, into a hue moment descriptor calculation, where we calculate our central moments and our scale invariant moments. This will give us a feature vector of shape unique identifiers. We can use that feature vector to train a classifier. So in this project, we looked at 3 different classifiers: k-nearest neighbors, support vector machines, and random forests. We can also test our classifier using a reserved bank of videos that were not trained on. First, we evaluated the performance of our 3 different classifiers across different values of tau. As you can see in the left image, our random forest classifier outperformed both the SVM and the KNN, and it showed robustness across various values of tau. We used the random forest classifier to generate the confusion matrix that you see on the right from our test videos. We see good performance along that diagonal and a little bit muddled performance in the upper left, where we are often confusing boxing and hand clapping. We then apply the same trained classifier to a video that contains multiple actions. We generate our MHI from a rolling 20-frame window, which we then pass into our classifier. Using our sklearn package and our random forest classifier, we're able to see the predicted weights for each category. We overlay those on top of the video, and you see that in the screen grabs to the right. There are some big challenges with actually using MHI as an activity recognizer. One of the main challenges is isolating your subject properly. If you see the images on the right, they're the same action, boxing, but in the top image, the subject is moving, and in the bottom one, he's standing pretty stationary. This creates quite big discrepancies with your resulting image. You can try and get around this issue by adding more training images to capture both those potentials, but you start to blur the line between different classes and you're going to hit a hard upper limit on your accuracy. You can also try and track individual body parts and features, hands and feet, but this adds a degree of complexity with implementing that tracker, and then you lose some computational benefits. The bigger challenge is actually that your subject must perform the activity exactly as they are trained. It's more motion recognition than activity recognition. This is a pretty killer flaw. You really can't achieve robust results in real-world settings using MHI as activity recognizers. For links to the video in the previous slide, please see the full project submission. Thank you.